Alright, so we've got another 1/2 inch thick single V-groove weld coupon, and we're going to be looking at a root crack in this area here. And let's see what this looks like with fast first. Alright, let's take some scans. Let's do a setback scan on this side. And here we go. Yeah, there's something there. Let's try that setback scan from the other side. Oh yeah, that looks like something definitely. Alright, let's do a setback scan from this first side, near the side near me. Right up close to the weld. Oh yeah, definitely something there in that area. And let's do it right up close to the weld from this side. Oh yeah, so we know we've got something here. And I think that did look better when we were up close. That's walking like something at the ID. Let's look at it from this side. Yeah, I think that does look like something connected to the ID, and it looks like maybe I go over the top of it. We're at about 365 deep. Let's get our thickness in here. Let's look at this trig menu. Yeah, let's put a thickness of 500 in there. I might be going over the top of something there at about 320 deep. But we can probably do that sizing better with our shear. Let's look at this with 70 shear next. Okay, we're ready with our 70 shear. And let's see what we have when we go by this. So I think I'm seeing a pretty nice root signal there. And the flow when it comes up seems to coincide with that somewhat. Let's try this from the other side. Harder to recognize the root from this side, but I could tell that there's definitely looks like an ID connected flaw. And this might be a tip signal very close to it with the 70. I'd rather size a tip with a different angle than 70. And where that front signal right over the top of that is at around 400 deep. So that also looks like an ID connected flaw. Let's look at this with 60. Alright, let's have a look here. Alright, that looks like my root signal. I'm following that along. And when I'm at the flaw here, I do have a little signal that comes up just before it. So I think that's just barely the other side of that convexity at the root. Let's try this from over here. Alright, so I think this is our flaw. And I think what I have here is an ID connected corner and a tip in front of it. And let me, Okay, so it's about 400 to the tip. These flaws are artificially produced, and for some reason they're much louder towards the end there. All right, let's try this with the 45. All right, I'm going to do something a little different this time. I kind of have a feeling that, I'd like to get that in the first leg in there, but that's going to be tough to do with that weld crown. But if I can see 3 legs, then I can get that where I'm bouncing off the OD surface much closer in. So I'm going to try that. Let me do a little sketch of that on my notepad. Alright, let's have a look at a trick we can use here. So when that 45-degree transducer, where the wedge is hitting the weld crown, we can't get quite in close enough with that 45 to peek up on the corner or the tip in there. But that's leg 1. We might be able to get in there though, if we could bounce off of the OD from here. So if we could come in and use the end of leg 3, we might be able to get the corner and the tip. So I'm going to change my screen here so that I can see 3 legs, and we'll see what we can find. And we've got our thickness in here, thickness of 500. I'm going to go in the display setting, and I think I went by. There it is. I'm going to change this to the leg display. And that's the end of leg 1, that's the end of leg 2. I want 3 legs, so I need more range. So I'm going to go into my range here. And alright, now we've got 3 legs. Leg 1, leg 2, leg 3. And I'm going to go ahead and bring my gate out to here. And alright, let's go in and have a look now. And here we are in close. And I don't think I might be able to peek up on the corner, but I can't peek up on that tip. So I'm going to pull back. And now at the end of leg 3, I've got the corner. Here's our corner trap signal right at the end of leg 3. And I'm trying to peek up on the tip here. And I think I have it now. There's the corner. And I think that's the tip. And I'm going to add some gain. So our corner, when we're peaked up on it, it's near 500. And come on, tip. Alright, there's our tip. I'm going to add some more gain. And so I'm seeing the tip at 360. So I'm going to freeze that. And I'm going to get my surface distance here to the well toe, and we can do some indication plotting. Index point to the well toe is 1.1 inches. I'm going to make a note. And let's go do some plotting. Alright, let's see if we can plot this. Okay, we're using the 45, and the index point to weld toe, that was 1.1 inches. There's our weld toe. So that's where our index point is. And on our plotting device here, this is the 45, the 60, and the 70. So let's put the index point right on the mark. These two lines are going to coincide. 45 line, 250, 500, 750. So we're just about 700 in sound path to there. So I'm going to put 700 to there. And I want this line and this line to be parallel. Okay, 751, 1, 2, 1 1/4, 1 1/2, so a little bit shy of 1 1/2. That's going to get us to here. That's where we're going to bounce down towards that, let's see, what did I say? That was 700. That's about 1.4 inches to there. So now we're going to go from about 1.4 inches, and I want this line and this line to be parallel. One 1 1/4, 1 1/2, so 1.4 inches. Those two are parallel. So we want to go to 1.929. 1 1 1/4, 1 1/2, 1 3/4, 2. 1.929. 1.929, that's going to get us to right about there. Right about there. And we've got a depth to the tip of 364, and that works out just about right. So we're going to say that that's our crack. And the flaw height, our thickness is 500. Our depth to the tip is 364. 500 minus 364 is 136. 136 inches. That's our flaw height. And this is where we have our root crack. All right. Okay, thanks a lot.